Welcome to today's session of linear programming. Today we are going to solve a problem using the simplex method. So in today's session we are going to begin with a maximization problem. In the subsequent session we are going to do minimization problem. So let's begin with the problem. Let's to the problem first. So this is the problem on the screen. You can see this is a maximization problem. So there is um, the objective function and also the constraint. Now you can see that there are more than two variables. There are three variables, and so it is not easy to solve this graphically. So we are going to use the simplex method, which is actually a kind of algebraic method. And so we are going to convert this set of constraints into um, a set of equations. So let's see how we can do this. So you can see that the problem is here, it appears on the screen. And let's begin with converting it into equations. We can see that this left hand side, since uh, this is in equation, you can see that the inequality says that this left hand side is less than equal to 250. Now, suppose this left hand side is less than 250 by some amount S1. So we can, if we add that S1 to this left side, we will get an equality. We can equate it to 250. Now, this S1 can be greater than equal to 0. So then equation becomes 8x1 plus 2x2 plus 3 plus S1 is equal to 250. Same way, in the second constraint, we let's say S2, um, the amount by which this left hand side is less than 150. So we can add this S2. This new variable here, I have added S1. This is known as a slack variable. So I'm going to add another slack variable here in the constraint, and we'll get 1x1 plus 3x2 plus s2 is equal to 50. In the same way, in the third constraint, we write 2x1 plus x3 plus s3 is equal to 50, where s1, s2, and S3 are greater than equal to 0. If they are 0, that means the constraint is exactly satisfied. There is no slack. So these three that we have added here are the slack variables. So we get a set of equations. So the set of equations look like this. So we have added all the slack variables. Here the coefficient is 0 because here these two slacks are not applicable. Here only slack S1 is applicable, but we have written this so that we get a complete matrix. So if I write this set of equation in the matrix form, then I get a matrix like this. Okay, I'm writing the coefficient. So 8, 2, 3, 1, 0, 0. So 0, 0. The next set, that is 4, 3, 0, then 0, 1, 0. And the last one, 2, 0, 1. And then there is 0, 0, 1. And this is equal to sorry, 250, 150. So I have written this in a matrix form, right? Now you can see that we have a set of three equations, but there are six variables. So we can only have solution for three variables. Now one thing you can notice over here is that this one, this part, you can see this is an identity matrix. So actually here we can get an initial solution if we set x1 and x2 and x3 to 0. If we put them 0, that means I write it in this way. I write x1 is equal to x2 is equal to 0. Now, if I do so, what am I getting? I'm getting um, a matrix which looks like this. Let me write it here. A matrix which looks like, because I've set x1 and x2 equal to 0, so I have, uh, well, I think I'll write it once again. So this was actually 8, 2, 3, 1, 0, 0, and 4, 3, 0, 0, 1, 0, and 2, 0, 1, 0, 0, 1, and we had initially there's six variables which are there, that is x1, x2, x3, s1, s2, s3 equal to 550, sorry, um, 250. So I have 250, this 250, 150, and 50. So this was the matrix, and I have told already that let's set, since this part is identity, let's set x1, x2, x3, these three variables equal to 0. So my matrix will now look like this. I will remove this and I will write S1, since I have already set x1, x2, x3 is equal to 0. So I have S1, S2, S3 is equal to this set of constants. Now you can see, since this is an identity matrix, I can write this, I can simply remove this because its value is 1. So I can simply uh, remove this. And so I have initial solution. What is the initial solution? You can see from here, the initial solution that I get is that S1 is equal to 250, S2 is equal to 150, and S3 is equal to 50. Right? And since the coefficient of S1, S2, S3 in this function is 0, and since I have also x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0, I also have here this z. I have z equal to 0. But I have an initial set of solution, and this is known as the basic feasible solution. Now, why is it the basic feasible solution? First of all, it's feasible because you can see all these three constraints are satisfied. Because here you can see this is satisfied. S1 is equal to 250, here S2 is equal to 150, and S3 is equal to 50, and rest is 0. So the constraints are satisfied, so it is feasible. And secondly, we have an initial basis because we had an identity matrix, and so we found one a set of three variables which are linearly independent. So we have a basis. So that is a basic feasible solution. And if you've seen the previous video on solution by the graphical method, we saw that the solution is one of the extreme points, and the one extreme point is the origin, where the decision variables are zero. So you can see that this is actually a basic feasible solution, which is an extreme point. So what we do is we have to go to the next extreme point because here z is equal to zero, and our objective is to maximize this z. So we have to find the next extreme point where value of z will increase. And since we have x1, x2, x3 is equal to 0, we have to make them positive. Surely we can find that, and that is what simplex does. Now, we have found this initial basis, and we can also include the z into the matrix that we have. So, in that case, how will the matrix look like? Let's um, take a little more time, and because this is actually building the concept, because if we learn simplex mechanically, uh, because see, we can always use software to solve linear programming problems. But why are we learning this? Because this will make us understand that how we arrive at the solution for a linear programming problem. So say this is Z, and we can write this in the form Z minus 20x1 minus 6x2 minus 8x3, and since this is 0, we can simply write plus 0s1 plus 0s2 plus 0s3 is equal to 0. And since the coefficient of z here is 0, say I can simply write 0z plus this constraint 0z plus this constraint 0z plus. So we have a matrix which includes z, and it will look like this. Will have 1, 0, 0, 0, and will have minus 20, 8, 4, 2. Will have minus 6, 2, 3, 0. We have minus 8, 3, 0, 1. And we have 1, 0, 0, 0, 0, 0. Um, okay. Here this coefficient is 0, so this will be 0. For S1, this will be 0, 1, 0, 0. So this will be 0, 1, 0, 0. For S2, again we'll have 0, 0, 1, 0. So we'll have 0, 0, 1, 0. For S3, we have 0, 0, 0, 1, which is equal to, now this constant is also included, this 0. So we have 0 to 50, 150, and 50. Now see if we set x1, x2, x3 equal to 0. So this part vanishes because we have set these three variables. Okay, I have to write the variables as well. We cannot miss that, so I'll write the variables. Um, So what are the variables? Variables are z, x1, x2, x3, s1, s2, s3, and that is equal to 0 to 50, 150, and 50. So this is actually the matrix. Now, if we set this part equal to 0, we have a matrix like this. And of course, these three will not be there. So how will the matrix will be a simpler one? So I'll rewrite this taking the three variables x1, x2, x3 equal to 0. So now we'll have a matrix which looks like this. Um, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. Again, we have an identity matrix, but now we have included z, so we have four variables where z is the um, say objective function, so objective variable, and then we have s1, s2, s3, and we have equal to the constant 0 to 50, 150, and 50. So you can see that we have the initial solution, which also gives me the initial value of this z. So we have z is equal to 0, s1 is equal to 250, s2 is equal to 150, and s3 is equal to 50. Now, if I remove this part, because this is an identity matrix, this is equal to 1. So if there is 1 just before this, we can simply remove it and we have an initial solution. Now we represent this in the tabular form. So that is where our simplex algorithm begins. So this part was just a preparatory part so that we get a concept about what simplex is. So next we move on. Okay, so now I come to this table and we can see that Um, the matrix that we had written is now represented in this tabular form. And here row 0 is the shows the coefficient of the objective function. And row 1 shows the coefficient, and row 1, 2, 3 actually shows the coefficients of the constraints. And the right hand column shows all the constants. Now, what we have initially is that z is equal to 0, and we have the slack variables, which are positive, but the objective, the decision variables are 0. We have to bring in the decision variables into our basis. Now, which decision variable do we start with? We start with the variable which has um, the maximum coefficient, the maximum weightage into the objective function. And we can see x1 has the maximum weightage. Because this is 20, because I had this minus 20 over here because I've written it in the form of z minus 20x1 minus 6x2 minus 8x3 um, plus s1 s2 s3 is equal to 0. So that's why it is negative. But if I write z is equal to 20x1 plus 6x2 plus 8x3, then we can see that x1 has the highest weightage. So first we'll make this one as the pivot element. So this is the incoming variable. And we have to decide which of these s1, s2, s3 it is going to replace. Now, how do we decide on that? What we do is that we divide all these constant by the coefficient of this incoming variable. Why do we do that? We do that so that we get that particular pivot element for which all the constraints will be satisfied. If I take a particular, if I see if it is replacing, say, S1, then x1 will be equal to whatever constant is over here. It might not satisfy the other two constants. So we have to get a feasible solution. So what we do is we compute the displacement quotients. We divide 250 by 8, we divide 150 by 4, and we divide 50 by 2. So we get 25 over here, we get for 3s 12, for 7 37, which is higher than 25, and here also we have 3s 24, something around 31. This is the lowest. So this has the lowest displacement quotient. So this coefficient, this part, this will be my pivot element. So I will pivot around 2. What does that mean? If I pivot around 2, that means this will become 1 and this has to be converted to 0. So we start with our first step. Since we have already decided on the pivot element. So we know the column, x1 column, and we know row 3. That means it is going to replace S3. And so let's begin with the exercise. So we have to make this 2, we have convert this to 1. Simply we divide this by 2. So we divide row 3 by 2. So that this pivot element becomes 1. So we divide this by 2, it remains the same. We divide this by 2, remains the same. This is by 2. Half. This is again 0 will remain the same. This one will remain the same. This one. This is again half. And this, if we divide by 2, we'll get 25. So we get the first step. So let's go to, so we have got the first pivot step and let's go to the next exercise. So first thing that we have done over here is we divide this entire row by 2 because we initially had 2 over here and 0 and 1, 0, 1, and we had 50 over here, isn't it? So we divided, to make it 1, we have divided it by 2, right? So we have got, so initial pivot. What was the initial pivot? To divide the pivot element, to divide the entire row by the pivot element. So if pivot element was 2, we have divided the entire row by the pivot element. Next conversion is we have to make these, all these 3, we have to make it 0 because it has to be a part of the basis. So it will replace S3, so it will be 0, 0, 0, 1. So how to make that? We can multiply this with 20, and if we add this 20 over here, this will become 0. So that means my new row 0 will be actually, how do I convert this row 0 will now change. This will become row 3 to 20 plus row 0, right? So if I add, multiply this, I multiply this with 20 and it remains 0, so there is no change over here, it remains the same. In this case, I multiply this with 20 and I add this 20 over here, so this becomes 0. So this becomes 0. Since this is 0, there is no change over here, this remains the same, right? Again, I multiply this with 20 and what I get is 10, right? So if I add this 10 over here, what I get is 2, right? And here also there is no change because this is 0. Here also there is no change because this is 0. Here again there will be a change. I multiply this with 20. I have 10. I add 10 over here. So I have 10. I multiply this with 20. What I get is 500. I add 500 over here. And so this constant becomes 5. right? So we have done the second pivot step. Next, arrived at the first pivot step because you can see that we have converted this, we have changed row 3 so that this element has become 1. Now, next step, what we are going to do is we have also converted these to 0 in the second step. And so what we are going to do is now we are going to convert this second one to 0. Right now, how do we convert this to 0? We multiply this with 4 and we deduct this 4 from here, this becomes 0. So how does this step go? We have the new row 2 in this form. That is, um, row 2 is the row 2 that is existing minus row 3 into 4. So here there will be no change. Here we have multiplied this, deduct this with 4, we get 4 and we deduct this from here following this uh, the formula that you've written. So this becomes 0. Now this will not change because since this is 0, so 0 into 4 will be 0 and so here there is no change. I multiply this with 4, I get 2 and I deduct this from here. And if I deduct this from here, uh, I get 2, so this is minus 2. So finally, this element is minus. This is 0, so there is no change. This is 0, there is no change. I multiply this with 4. I again get 2, and this is again minus 2. Finally, I have 25 into 4, that is 100. And of course, this is not changing. I'll deduct this from here and I get, this is not changing, this will remain 25 because I'm changing row. So we get our new step, we get new row 2. We have converted row 2. So we have converted this to 0 and this to 0 and we have one more row left, that is row 8. Sorry, row 1. So we have to make this, we have to make this 8 equal to 0, right? How do we do that? We multiply this 1 with 8 and we deduct this from 8 and so we can get 0. So what is the step over here? So new row 1 will be the existing row 1 minus row 3 into, if I put 0 into 8, there will be no change. So here there is no change. Here I have already changed it to 0. This is 0, so there is no change here. This is half. So I'll multiply this with 8. This will become 4. And I deduct this 4 from here, minus 4. So I have minus 1 here. There is no change here, no change here. Again, this into 8. That is 4 and I have minus 4. So simply I replace this with minus 4. Then again 25 into 8. I have 200. I deduct this 200. I have 50. So I replace this element with, so I have done the final pivoting so that I get another new basis. Right? So we have got a new basis, and in this new basis we can see that we have actually brought in x1 into the basis and we have replaced s3. So now in our solution we have x1 is equal to 25 because this is a part of that identity matrix. So x1 is equal to 25. We have s1 is equal to 50. We have this is pertaining to s2, so we have s2 is equal to 50. And we can see here what is this z. So we have z is equal to 500. So we have got an initial solution, but we have to optimize it to maximize, isn't it? So we still have scope of maximizing because we have this again minus 6. So if we bring in x2 into our basis, we can still increase z. So let's do that. So what again we will have to find our pivot element. So incoming element we have already decided on. This has to be x2. So we write this is the incoming variable. To decide on the outgoing one, we again find the displacement quotient. But since this is 0, because 0 it means that in this constraint it's x2 variable is not there. So this is not relevant. So we need not find the displacement quotient here. We divide 50 by 3 and we divide this 50 by 2. And of course, we can see that this is smaller. Right? So this is going to be my pivot element. Right? So this is pivot element. I'll make this one and I'll make the rest 0. If I make this one, that means this is going to replace this particular, that means it is going to replace S2. Okay, and I have to do the conversion as I did before. So how will the conversion be? So I this as my incoming variable. So this is the incoming variable, and this is the pivot element. I'll divide this entire row, row 2 by 3, so that it becomes 1. So I divide this by 3, this by 3. There is no change. I divide this by 3, this becomes 1. This is minus 2 by 3. There is no change. Here, this is 1 by 3, this is minus 2 by 3, and this is 50. So I have got again I start another pivoting, another set of pivoting. So got table 2 now, I have to by and by move to table 3 through some of the pivot steps until I get x2 into the basis. So that means I get 0, 0, 1, 0. I have to simply make it 0, 0. So let's move on to the next. So what we do is we divide this by 3 as we have already found out our incoming. And so we divide it by 3 and we find out our fourth step. We have divided it by 3 and we get this step. We have to make this 0. Alright? Since minus 6, we are going to make it 0. How do we make it 0? We simply multiply this with 6 and add it to here. We add this 6 over here and so it becomes 0. So what step have we done? We have simply got a new row 0, which is the previous row 0 plus row 2 into 6. So we have done row 2 into 6 and we have added to row 0 to make it 0. To make this minus, convert minus 6 to 0. We do the same thing. So here for these two, there is no change. This one and this one, there is no change because they are 0. Here I'm going to multiply this with 6. So I get minus 4. And so minus 4. So this will become minus 2. Alright. And here there is no change. Here again I multiply this with 6. I get 2. I add this, I get. I multiply this with 6. I get minus 4. Um, right? So I get minus 4. So 10 minus, and then again I have, so 10 minus 4 is 6. So this is 6. And again I have this into 6. So I have 100. I add 100 to this. And what I have is 6. Right, so we have done one set of conversion. Okay, so this conversion is done. So we have here, we have this. This is 600. Right, so we have done this conversion. So in the next step, we are going to convert this to 0. So how do we do that? Multiply this with 2 and deduct this 2 from here. So what is this step we are doing? So if I multiply, if I deduct this 2 from here, we get a 0, so we have to make this 0. So then I apply this to the whole row as I did previously. So my new row 1 will be row 1, the row 1 minus row 2 into 2, right? So for these two, since they are 0, there is no change. But for here, I have already made the change. So this is 0. Here I'm going to multiply this with 2 and I'm going to deduct this from here. So if I deduct this, I get 4 by 3. So this will be plus 3. Alright. So what I get is, yeah. So I get 4 by 3. So I have 1 and 1/3 minus 1. So I'm left with 1/3. Here there is no change. Here again there will be a change. I multiply this with 2 and deduct this from here. So I have 2 by 3. So I have minus 2 by 3. 0 minus 2 by 3 is again minus 2 by 3. Again here there is a change. I multiply this with 2. I have minus 4 by 3. That is minus 4 by 3. That is plus 4 by 3. All right. So I have um, minus 8 by 3. Okay. Yes, I have minus 8 by 3 over here. And then I'll multiply this with 2. I have 100 by 3. So I deduct this. So I have 50 by 3. So I have done another pivoting and then I have got a new basis. So this is a new basis. So again, I have got another new solution. What is the solution? I have, can see both x1, x2 are into the bases, and of course s1 is into the bases. Of course, z is there into the bases. So now I have x1 is equal to 25. I have here, you can see x2. So I have x2 is equal to 50 by 3, and I have s1 is equal to 50 by 3, and I have z equal to 600. So I have managed to increase z first from 0 to 500, now 500 to 600. So is it possible to further increase it? Yes, it's possible. Why? We again have a negative coefficient for a decision variable. So that is minus 2. So we can again bring in x3. So we can make another incoming variable over here. Right? So we can make it an incoming variable. So let's do that. So we have got this table 3 and initial solution. And again, we'll start with a set of new pivot steps to bring in this variable x3 into the basis, right? Let's see how we do that. So here we start with the pivot step, and we know that this x3 has to be the incoming variable because all x1, x2 are 0. Only this has a negative coefficient. That means it has the power to increase z. So we bring in x3, but again we have the question which one it is going to replace. Now here we see that um, we can see that we cannot consider this because this is negative. So we again divide this 25 by half. Okay, so it becomes 50, and we divide 50 by 3 by 1/3, and this becomes equal to 50. Now, what we do here is that let's begin with, we can take any of the two, and let's decide to take this one because this is half, and simply if we multiply this with 2, it becomes easier to do the pivot step, right? Because we have to convert this to 1. So this is our incoming variable, and sorry, x3 is our incoming variable, so this is the pivot element. So we are going to pivot um, this column in terms of this particular pivot element. So make this 1 and rest will be equal to 0. Right, so let's do this pivot step. That is, we simply multiply this with 2. We multiply this entire row with 2. We multiply this with 2, and we'll get 2 over here, we'll get 0, we'll get 1 over here. This is 0 again, we'll get 1 over here, and we'll get 50 over here with this. We multiply this. Okay, so let's do the pivoting. So we have done the pivoting here, and we've got 1, we've got 50, we've got 2 over here. So we've done the first pivot step of this bringing step towards bringing x3 into the basis. Now what we have to do? We will make this one 0. This minus 2 has to become 0. How to make this 0? We simply multiply this with 2 and we add this to here. So it will become 0. So again, I write a new row 0, which is the earlier row 0, which is earlier row 0 plus the row 3 into 2. So in this case, this is 0, there is no change. This is row 3, right? So if I multiply this with 2, this becomes 4. And I add this 4 to here, and this becomes 4. Here there is no change. Here I have already made it. So this has become 0. There is no change here, no change here. Here there will be a change. So I multiply this with 2 and I add this and it becomes 8. And here there is a change. I multiply this with 2 and I add this. This becomes 100. I add this 100 over here. So this becomes 600 because this is 100 and I have added this 100 over here. So this becomes, sorry, um, this becomes 700. Right? So I have increased Z, right? So next step will be is to make this element equal to 0, and um, so how do we do that? Let's move on. So I have already made this change. Let's move on to the next step. So we have got this 0. Now we will move to the next step where we make this 0, right? So we will make this element equal to 0. So how do we make 0? We um, divide this 1 by 3, and if we deduct from here, we make we deduct 1/3 from here, we can make it 0, right? So let's do that. So here we've already done, made it 0, and let's write the new row 1. So new row 1 is the current row 1 minus row 3 by 3. So here this is 0, no change. This is 2 by 3, and so this will be minus 2. Right? There is no change over here. This is already, we have made it 0. There is no change here, no change here, but here there will be a change. So we divide it by 3 and we deduct it from row 1. So this will be minus 1/3. Okay, so that will be minus 9 by 3. So that will be minus, right? And this is, we make this 50 by 3 and we deduct it from here. Minus 50 by 3, what we get is 0. Okay, so we make the next pivot. So next we have, uh, we already have 1 over here, we have 0 over here, and we have to convert this to 0. So what we do is we multiply this with 2/3 and we add to this. So we get 0. What is the conversion? Conversion is new row 2, which is the old row 2, the existing rather. We add with that row 3 into, right. So what we have here is we have um, this one will remain unchanged. This one will be multiplied with 2/3. That will be added to this row 2. So I have plus 4 by 3. So this will be replaced by 4 by 3. There is no change over here. Here I have already made it 0. There is no change over here, no change over here. Here again I multiply this with third and I add this to third over here and I get 0. Over here also I multiply this with third and I get 100 by 3 and I add this 100 by 3. I get 150 by 3 which is equal to 50. So I get again a new, right? I get a new step over here. I get 50. So what we have done here is that we have replaced x2 and x3. We have replaced um, x2 and of course we have replaced x1. We have x2 and x3 into the basis. So what we have no further scope of changing the solution. So this has to be the final solution because you can see there is no negative coefficient pertaining to the decision variables. This is our final step, and so our final solution that we have got here is x2. You can see, as you can see, this is 1. So we know x2 is equal to 50, x3 is equal to 50, and 1, of course, is out of the basis, so x1 is equal to 0. So here we can see S1 is equal to 0 and Z is equal to. Okay, so if I want to write it in the form of the matrix, actually I have 1. So let me write it in this form. If I write it in this form, it is the identity matrix with the basis. I have 1, 0, 0, 0, and I have 0, 1, 0, 0. Then I have 0, 0, 1, 0, 0, 0, 0. Then I have this 0, 0, 0. I have this identity matrix. And what are the variables put into that? First one is Z. The 0, 1, 0, 0 is S1. The 0, 0, 1, 0 is X. And the 0, 0, 0, 1 is X. I have 700. I have 700. Then I have 0. Then I have 50. Then I have 50. So here I can see Z is equal to 700. X1 is equal to 0. X2 is equal to 50. X3 is equal to have this objective function. I can see that my solution I had got that is x1 is equal to 0 and x2 and x3 50. So I have z is equal to 20 into 0 plus 6 into 50 plus 8 into 50 and rest are 0. So I have 300 plus 400, that is 700. Because 6 5s are 30, 300, 8 5s are 40, 400 is equal to 700. And here if I see x1 is equal to 0, so this is 2 into x2, that means 2 into 50, that is 100, and plus 3 into 50, that is 150. So what that is, sorry, 3 into 50, that is 150. 3 into 50. So this is 150, this is 100, so I have to. So this satisfies the first constraint. Then I have again this is for x1, so x1 is 0. So 3 into 50, that is 150, and we have 150. And this one again, this is 0. I have this one, x3 is 50. That's why I have 50. All the three constants are right here, exactly satisfied. And that should be because all the slacks are. So we have got a solution, we have maximized Z, and uh, we have uh, found the values of the decision variables. So we come back with minimization simplex. Okay. So till then, good.